lecture, we will analyze the inventory planning process. The main goal of the inventory planning process is to meet the customer needs while ensuring a target service level and minimizing the total costs. Different types of costs and their trade-offs should be considered, specifically the inventory carrying costs, the other production and logistics costs related to setups, transport, order issuing, and so on, and the costs deriving from poor service levels, such as delays and stockouts. The structure of the inventory planning process can be represented with the scheme shown in the picture. So, in order to describe the process, we have to define the inputs, the activities with the related actors and the adopted methodologies, and the outputs and the key performance indicators to be measured to check if the process is under control or not. Let's analyze more in detail these main elements. We can start to analyze the output of the process, which consists in the definition of how much, when and where to hold the inventories in the system. In fact, typical questions we have to be able to answer are: how many stocks should be kept in the warehouse? And when do we have to make a replenishment order? Where do we have to hold the stocks? That is, in which warehouse of the network? In order to obtain these outputs, we need several inputs. The demand plan, detailed per item and location in terms of both demand forecast and expected accuracy. This plan is the output of the demand forecasting process. Then we need to know the target service level, for example, the desired item fill rate, the replenishment lead times, and the relevant costs. That is, which are these costs? For example, purchasing costs, transport costs, inventory carrying costs, and so on. And what is the cost structure? Regarding the inventory planning activities, they consist in the definition and implementation of the replenishment policy for each item and for each node of the distribution network. Two choices should be made. First, the management policy. For example, we can decide to make an order every time the stocks in the warehouse reach a minimum predefined value, that is, a reorder point. Or we can decide to make orders with a fixed order frequency. In addition, we have to choose the management parameters, such as the reorder point. For example, we make an order every time the inventories are lower than 100 pieces, or the replenishment frequency, for example, once a week, once a month, and so on. Like in all processes, it is important to measure the process performances in terms of both efficiency and effectiveness. Regarding effectiveness, it can be measured through the item fill rate. The item fill rate is calculated as the ratio between the available quantity on hand, that is annual demand minus annual units in stock out, and the requested quantity, the annual demand. Indeed, it represents the percentage of items fulfilled from stock, calculated on the total number of required items. Another indicator to measure the effectiveness is the probability to avoid stockouts. It represents the probability of being able to fulfill all the orders from a stock in a certain period of time. In order to better understand the difference between the item fill rate and the probability to avoid stockouts, let's see an example. If the desired item fill rate is equal to 95%, it means that the maximum quantity of the required items that are out of stocks is equal to 5%. Therefore, the focus is on the required quantity. Instead, setting the desired probability to avoid stockouts equal to 95% means that a stockout can occur in no more than the 5% of the cases. Therefore, this time the focus is on being able to fulfill all the orders in a certain period of time, but the indicator is not able to distinguish a situation in which the stockout is related to one single unit from another situation in which the stockout is related to a higher number of units, for example 100.